Okay, welcome to the Electron Injection Podcast. I think it's an engineering podcast. I keep throwing that little stuff in that keyword in there. I don't really know why I do that. First off, what have I been up to? I've spent a majority of this week working on my synthesizer. I have 7 PCBs that I'll have to glue together, and currently I'm trying to hook up 2 together. And it seems like every single thing that could go wrong has gone wrong. You know, Dave Jones from the EEV blog, he's always talking about Murphy's Law. Murphy will get you every time. Murphy has gotten me more than every time. How can you do that? Every single thing goes wrong. I mean, I designed this thing on the breadboard. I mean, I could show you. Well, it's not on. Well, just hang on. Let's look at this. For you audio people, too bad. I'm looking at on my bench. There it is. A big pile of crap. Those wires. It's a disaster. And there we go. It's an absolute disaster, but it works. It does what I have a monophonic synthesizer on that board right now that works fine. Everything that I did, I put in KiCad, and I made the PCBs. I mean, I make mistakes. I forgot a resistor that kind of mattered here, and this and that. But I've had every single link of the chain has broken, and I just keep on persisting. I just keep whittling it down, and I keep thinking like, man, Brandon, your brain isn't made for this. Maybe you should just have been a administrative assistant, or like there's a part of you that just really wants to beat yourself up. And I guess my view on that is that guy can go eat a big turd. I'm just going to keep on persisting until they kick me out. And that was my plan in engineering school, because good God, like trying to keep up with that, almost no one could. Plenty of capable people in school, no one could keep up. And so you just learned, I'm going to do my best. And there may be a day when they sit me down and say, Brandon, you are not allowed to be an engineer. You're way too stupid. You don't have it. But until then, I'm just going to keep doing it. And so far, they haven't kicked me out. So whoever they is, there is no committee, kids. So boys and girls. So just remember that even if you're feeling down on your luck and you're getting your ass kicked, just keep going. Shut off that little voice. Just keep going. Take a break if you need to. Take a shower, whatever. Take a run, whatever you got to do. But just keep going. So yeah, the synth is kicking my butt. And there's those voices of telling you, oh, this thing was supposed to be done in October, and now it's February. What's wrong? Blah, 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 blah. Well, this is my first time doing this, so it's just going to take a while. But I didn't expect to have to design it again, which I've kind of had to do, sort of. So anyway, I guess I underestimated the switch over from breadboard to PCB. The problem is, I guess I've done a lot of small boards. You just do a little breakout board for a microcontroller with blink some LEDs or whatever. That's one thing. But when you suddenly have like 30 things going on, you just more stuff breaks, and you need more Bosch wires, and it's you're more likely to not catch the issues you may have caught with a small board. Small board with 2 functions, you only have to pay attention to 2 things, and when you have to pay attention to 30 things, life's harder. It's trickier. And so, what are you going to do? So I guess keep on going. And I just finished up a board called Tactile Switch Female Dog. It's 16 tactile switches, all connected to an expander. And the idea is, it's just I2C, so you have these 16 switches on 2 wires, data and clock. Of course, you got to power the thing. But this makes it very easy to add a ton of buttons if you have a project that requires that. And so it's a dev board, so it's designed to be in that preliminary breadboardy type state. Although I guess you could use it in a real product. I mean, there's no reason not to, other than it's pretty large. But I use that with my synth. I have a Rev 1 that I did with my synth, and I loved it. And it's just incredible because I actually used 3 of them. So I have 48 switches, and I2C. I actually was able. Did I even use 6 wires? I think I knocked that. I think I was able to share some of those lines. I don't want to tell you wrong, but long story short, what a powerful tool to add 48 switches to a microcontroller with just a couple wires from I2C. So I finished that up, and I'm going to go ahead and manufacture those through JLC PCB, and we'll do a few. If any of you guys are interested, then let me know. I have no idea how you're going to find this podcast or why a person would buy them from me or whatever, but they will be on electroninjection.com soon enough. And then, of course, from last week, I think we talked about the encoder exploder. And that similar dev board, similar thing where I used it on the synth project. It's a breakout board, essentially, a dev board. So, yeah, not really a breakout board, more of just a dev board. But we have 4 switches. Excuse me, I'm all over the place. 4 encoders. And they've already been debounced, and they're all works through I2C also. And so, no thought, you just plug it in, 2 wires and some power, and you're good to go. And I've got a lot of my little extra stuff on there. Like, something I do that I haven't seen in any other board. I put power connectors on all 4 sides of the board. And when you make what's called an elephant board is when you have a board, 2 feet by 1 foot that ends up turning into a product. When you first start, the thing is huge. It's an elephant. And then over time, you shrink it down. PCBs get consolidated. Huge piles of wire turn into, a few tracks on a PCB. Things get smaller and more tidy. So whenever I'm doing those, they need to interconnect. And the boards all need either 5 volt or 3.3 pretty much. But then you have these long power power cords that run a foot, or less, more, whatever. You have all these wires, and for me, I'd rather just have like a little 1 centimeter little jumper for power, another one for ground. And by doing that, you shorten wires, you reduce your noise, particularly if you use a twisted pair. And most importantly, when you look at your board, instead of seeing 100 wires, maybe you see 70. It makes a huge difference on just noticing problems and that overall overwhelming feeling that you almost always get with when you have these gigantic boards. So that's what I've been up to this week. What have you been up to? What? I can't hear you because I'm not listening. It's a funny thing, like the interaction when you're making your own podcast and you're hoping people will listen, and then when you're listening to a podcast, you tend to respond. Like I will talk to my phone and say, "All right, you son of a," and I'll give my opinion, although no one's listening. Every once in a while, I'll email one of these, smaller podcast type guys who you kind of feel a closer connection with sometimes. And it's as if we're best friends. We've been hanging out in the room for years and drink 100 beers together. And then when you act like you're best friends with somebody, when you haven't earned that rapport, some people don't respond well to that. I pissed off Parker Dillman one time from the Macrofab podcast because I pretended we were best friends and I gave him some shit. Oops, sorry, gave him some crap. This is a PG-13 version. I gave him some crap, and he kind of responded. He didn't take it the way I intended, and I apologize that he intended it wrong because I was just messing with him because I thought he was a dude like me or you or a chick. You never know these days with the fluidity stuff. Here's something I noticed. This has happened twice in the past a week or two, where I'm soldering some really small stuff, and I'm usually a pretty careful guy. I don't have too many mega accidents, but when I'm working with these boards that I've jam-packed with stuff, and I'm trying to get in there in tight places, I've burned myself twice, and neither time did it bother me at all. Like I even had the little white part on my skin. You can't see it now, but the white part of my skin, I was kind of glad I burned myself, and not in like a sadomasochist. I don't like pain. It didn't really hurt, which is probably part of the reason I didn't mind it. But it was more like to someday when I'm a real engineer, like I would have burned myself, let's just say 1,000 times, and now I can just check off 2 off the list there. Kind of like the guys in prison with the chalk 1, 2, 3, 4 slash. I liked it because I felt like I was moving up in level. Experience points for you people into the nerdy games. Okay, so this episode, I wanted to talk about my favorite microcontroller. I have enormous, maybe not enormous, a pretty darn enormous collection of microcontrollers, dev boards, and I use almost none of them. Of course, I started out with the Arduino Uno, as everyone does. I started building stuff with it, as most people do, and then I realized that the breadboard wires on finished products is a terrible idea because they fall out. They get yanked out, or they're just bad. And so I progressed through all the ATmega 328 based microcontrollers, and which was good. And then you started hearing about EFM8 this, or some of the you know, the 32-bit ARM type stuff, you know, your Cortex series is you know, there's many of those, and then before you hear about these other features, and suddenly you realize, oh, the Arduino Uno couldn't debug, and so you learn what debugging is, and so you go through these iterations, these steps, and before you know it, you don't know who you are, and you just have this big pile of crap, and you don't know what to do with all of it. But so somewhere in there, I drew a line. I said, here's the features I want. And I was kind of at a point where I knew what I wanted, luckily. So I said, ooh, the STM32 Blue Pill looks good. And I'm going to make that my main microcontroller. And I decided the SP32 would be my secondary microcontroller, just because it has Wi-Fi and Bluetooth. This past year, I've done almost no Wi-Fi and Bluetooth, luckily. Luckily, I mean, I like that stuff too. So I've been able to focus on the STM32, and I just shove the Blue Pill and everything. Like, it's a given. I'm going to start with the Blue Pill, and we'll go from there. So I wanted to talk about why the STM32 Blue Pill absolutely destroys an Arduino Uno, for my money, and also some of the hang-ups and downsides to it. All right, so I got kind of this little checklist of crap. Blah, blah. Okay, so the one thing that I think is probably the biggest reason I chose the STM32 Blue Pill initially was scalability. For one, it comes in a little, form factor. It's a dev board. You know, you got to put pins on it and that type of thing. It's not just a chip that you would have to put on a PCB. Of course, you can easily put it on a PCB with a few female headers. That's no big deal, and I've done that, and I like doing that. But what's cool about STM32 is their series ranges from these tiny little STM32 L0 series, which are super low power and slow, not performance. I say slow, I mean still faster than Arduino Uno, or almost any of the 18 mega 328p type stuff by a long shot. But they're not designed for performance at all. They're designed to save battery juice. But then that series will range all the way up to the STM32H, which is, you know, you're getting into like Raspberry Pi land, where you have HDMI video and all that kind of stuff. Now, how much switchover do you have to make once you have your software, your development environment set up correctly for, say, a Blue Pill? For going to like an L0, almost nothing. Its switchover is quick. It's just pin names, and hopefully if you use macros, then you're set there. So the switchover is almost nothing. I'm sure moving up to like the super high performance 32Hs is a bigger step, but not near as big a step as switching from, say, an STM32 Blue Pill to like an Atmel chip or something like that. So I like the idea that if I run into a project that needs way more than a Blue Pill, well, it's no big deal for me to move up. So in addition to that, the STM32 has all those Nucleo boards and Discovery boards, which have their ups and downs, but they're cheap ways of getting into. If you want to collect a whole huge pile of dev boards like I have. Okay, so let's talk about some stats. First off, you get 3 serial ports on a Blue Pill. Well, why do you need 3 serial ports? I don't know, but I'm using 2 right now. I have my MIDI input on my synthesizer is using 1 serial port, and then I'm using a different serial port for serial debugging, you know, the printf type, or print, I guess it's printf and C, serial.print in Arduino, that thing where you see it on your terminal. So I'm using 2 right now. I don't know if I could use them, get by with just 1 or not. I'd have to look into that, not sure. But it's really nice to have 3. And yeah, again, do you need it? Who knows? That's up to you. But you get 2 SPI and 2 I2C. I come up with a reason. I can't remember why, but I did use 2 I2C buses on my synthesizer. But I'm pushing I2C hard. I mean, I got like 150 LEDs, like 48 switches. I mean, a lot's going on with this thing. Many chips are connected to it, and there was some reason that it was just a lot easier. Again, I probably could have forced it. I2C could handle like 128 different processors it talks to, or chips it talks to, but whatever. Here's a biggie. Interrupts on every single GPIO pin. Now, Arduino, you get 2 interrupts. With the Blue Pill, you get more like, I don't know, 30 or something, since you don't have to think about it. And that's been really nice for me. So a huge benefit is the interrupts on every pin. And that has benefits with coding and such. When you don't have to pull a pin and check it, you know, every loop through, like, are you on? No, you don't ever check it. You just let the interrupt tell you when it's on. That's a better way. And so you can actually get slimmer code. I'm selling this thing. I don't know why. I don't care what you use. Last one is pulse width modulation, 16-bit, and it's not on every pin, but it's on a bunch of pins. Here, we'll look at a quick diagram for you people that can see. I guess your YouTube types. I don't know. I don't want to penalize the audio types because I'm usually an audio dude, but we'll find a way to make this work for everybody. Okay, so here is the best. There is a picture. Google image it. You will see a STM32 with a white background, and everybody has all the pins, or all the pins are labeled. So far as pulse width modulation is concerned, I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like 15 or something. I'm not going to get specific. Like a ton. So, and they're all 16-bit as far as I know, which is hyper useful. And if you don't know why that's useful, make a project with pulse width modulation. You'll probably figure out why. Something you got to think about is 5-volt tolerance. Now, Arduinos are all, Arduino Uno, I should say, all the pins are 5-volt tolerant. It's a 5-volt device. It's if you have to use a 3.3-volt device when you kind of have to get creative sometimes. And the same applies only backwards here. So if you needed a, let me switch back. There we go. So if you needed a 5-volt device to use with the Blue Pill, which my synth is all using, like late 80s junk compared to modern stuff, because I'm trying to interface with stuff that's 30 years old. It's everything's pretty much 5-volt, and that means I need to use logic level converters. It's like a bucket chip, which is, whatever. I have to eat that, I guess. But not complicated, just a slight hassle, not a big deal. All right, so what else we got on our notes here? Okay, let's talk about the cost of this thing. This is weird. You can buy this chip for $2.50 on AliExpress. And if you go on DigiKey to buy the chip, it is $5.17 for 10. To buy 1,000 is $3. And that's as of last night. So you're like, well, how can it be so cheap? Is the Chinese government funding this? Is there some kind of illegal stuff going on? It's very hard to tell. And it definitely raises some ethical issues. Somebody's clearly doing something odd. Now, are they taking chips off of a line that failed the test and then just throwing them on the boards at midnight when no one's looking? I don't know. I don't want to invent conspiracy theories here. I mean, is it an underground pizza dungeon of STM32s? I don't know, but it bothers me, and it's so tricky because a board that's $2.50 that can do everything I need. Oh wow! But if I had to pay $18 for it, well, suddenly my projects are much more expensive. Now, again, I'm unemployed, so money's tight. Before that, I was in school. Money was tight. And so for me, like if you're in school, you kind of get a pass. And I guess if you're unemployed, you get a pass. But the second I have a real job or somehow like make $8 a day, I need to think about getting a fancier or paying for the good stuff. And we'll talk about that here a little bit more. But part of that whole whatever the Chinese are up to sell them this cheap, Maple Mini is more or less credited for inventing this thing. And as far as I know, they don't sell them at all. They don't even bother. So you hate to see a bunch of good people who invented a thing get put out of business by the copycats. And so I don't want to support that, but it's like, I don't want to starve either. You get the idea. So if you got the cash, look for a better alternative, and that a more ethical alternative. Know where your meat came from, that type of thing. But you may have to actually go hunt it yourself. That's where it gets kind of weird. I've actually thought about making and selling these and testing the crap out of them and only using genuine components. We'll see if anybody's interested in that. Okay, debugging. Now, there's debugging with the serial prints. That's one way to live. It's okay. It's useful. I used it yesterday. But there's the debugging with a debugger, where you get to actually scroll through the code, look at registers and all that kind of business. You get to see the value of variables. Arduino Uno, as far as I know, can't do it at all. Arduino Mini Pro can do it, but then you need the Atmel Ice programmer. I have one. It's $60, and you hold it, and you're like, they could at least put like a brick in here to help, make somehow rationalize all the steel needed, because to use debugging with like real deal debugging with a Blue Pill is about $2.50, $3. Again, those are clones too, and again, there's the logical debate, or ethical debate, I should say. Whether you should use them or not is up to you. I think the legit ST programmers are in that $10-$20 range, so even that's not that bad. I can't stand it when a programmer costs like $60. It's like I don't know why. It's just a microcontroller and like a case, just and a little bit of programming. Just give it to me for a reasonable fee. But so anyway, the Atmel version, which I guess is microchip now, it's just a little insulting, and it bothers me. I just don't want to pay that, and especially if I switch to another new family, then I have to worry about new programmers. So the debuggers are super cheap. Debuggers and programmers are kind of the same thing, so you know. Okay, and here's where things get. I already mentioned one of the downsides was the lack of 5-volt tolerant pins. I mean, there's some, but they're all kind of scattered all over the place. Let's take a look for us YouTubers, YouTube types. How many of these are 5-volt tolerant? It looks like almost all of them on that B side are, and then almost none of them on the A side are. So, well, I'm just going to go on a limb and say about half of the pins are 5-volt tolerant. So that's not terrible, but it can put you in a bind, particularly if you're doing what I'm doing, where you're actually interfacing with old stuff. Most people aren't going to be dealing with that much 5-volt, maybe? You decide. Okay, so reliability. Now here's the problem. Because I'm not aware of an American option. I did Google this yesterday, and I spent at least 15 seconds looking. I didn't immediately see an American option. I did see a Canadian option, which that's even worse than China. I'm not doing that. It's called Arduino, and it's on Amazon. The price wasn't terrible. The shipping was. I think after shipping, it ended up being close to $8 a pop, which for a legitimate board you can trust, and the reviews are really good on it. So if you're looking for an ethical option and you got a few extra dollars to spend, so far the Arduino seems to be the way to go. But you never really know what China is giving you with these things, and you might get a microcontroller that kills. It's just in a good way. I mean, it just works. It's as good as a $20, something you might find on DigiKey, and it just goes and goes and goes. Or you might just turn it on and never even powers up. You might power up for 3 seconds and die. They will stuff anything and everything into these things, and so when you're paying $2.50, you never know. And I've had, I thought maybe if I just bought from the same store on AliExpress, that would do it. And no, like you get what looks to be like genuine boards. And if you look at I don't know if it'll be in focus. You can't see it with this crappy webcam, but come on. Do it. No, it's not going to do it. Well, anyway, if you look at the silk screen on the chip, on the actual microcontroller, you'll see a really nice silk screen if it's legit. And if it's terrible silk screen, it's pretty clear that it's not legit. This is not something ST approved. So, but you never know what you're really going to get. And so I've had projects, like I made my wife this little LED flower thingy with plexiglass, and one of those usual fun hobbyist type things. And the microcontroller just died on it. And so because I was an idiot and soldered it directly to the PCB, I didn't use any headers. I had to basically just rebuild the whole thing, because desoldering 20 pins would take me longer than just rebuilding the whole project. So that's the kind of thing that happens with these. But then, again, I've had 10 other projects with no issues. And the big one is the 3.3 volt regulator. Those like to die. And so I highly recommend, what is it? Oh, here it is. MCP 1700-3302. So the MCP 1700, and just make sure you get the 3.3 volt series. I've had good luck with those, both SMD and through hole. There's probably others that are cheaper, maybe even better. I don't know, but I've liked those. And so what I like to do is use an external regulator right off the bat and just power it with that. So I send 5 volt maybe to my board, and then we'll knock it down to 3.3 and feed that directly to the whatever that input pin is. Yeah, if you're not sure about it, ask me. I'll look it up for you if you need to, but it's on the data sheet. So So by avoiding the regulator, you save yourself some pain. Of course, there's the cost of that regulator. I don't know what that cost. I haven't checked in a while. I don't remember it being that bad. So, and many of these you buy have the wrong resistor on USB. I think it's a pull-up resistor or whatnot. But if you want to actually use data, I never use the USB on these, by the way. I don't even bother. I only use my own ST-Link 2, ST-Link V2. Sorry, I'm confusing everything. And on some of them, the USB power is directly connected to your main power. So if you supply the board power externally, like I do, like I was just saying with the 3.3 volt regulator, and you plug in the USB, well, you might have two voltages that are slamming into each other, and that's a disaster. I don't want to imagine the input and output impedance of all those messes. So I always just cut that trace, or just never give it 5 volts from the USB. That's easy to solve because I just don't use USB. And to make things even worse, there is a copy of the actual chip. We're usually looking for it's the F103C8T6, but they put a CS32 instead of an STM32 in the front. So the CS32, I've played with some of these. I had to change some weird text stuff in Platform IO to get them to work, but I did get them to work. But then I've had projects where I'm just going to use the clone and we're going to see what happens. And then something will happen that's weird. It doesn't quite make any sense. And I'll end up going back. And going back to the ones that appear legit in both Platform IO and to my eyeball when I look at the silk screen. So that reliability part's an issue. So I would say 80% of mine have been fine. Or at least I know right away, right when I power it up, I know, okay, this thing's junk. But it does seem like we need a way to verify that we have good ones. And, of course, from AliExpress, I'll just send you anything. So I guess I don't want to be too hard on the microcontroller because on its reliability part, because once it works, it generally works. Again, that regulator might bust on you. But so, yeah, I don't want to overstate that because it's not been a huge problem. It's been a small enough problem that I still choose it as my main microcontroller, my default. So let's just kind of do an overall assessment here. Okay, so the cost is really, really low. And that's kind of hard to beat on a pure capitalism scale. But when you start thinking about the ethical issues and that whole too good to be true side of things, something's up. It does seem like something shady is being supported, or you're getting substandard parts, or something crappy is going on here. And, the finicky reliability is a pain. And, the price helps to offset that. And so maybe I'll just order 20 at once and throw out 4 right away because they're just junk. And then I got 16 pretty good ones. 3 or 4 regulators might pop. But if I use my regulator thing, I don't have to worry about that. So we'll say 16 decent 16 different microcontrollers for $20 or, $40, whatever. You get the idea. You get it cheap. Now, the programmer is outstanding. And again, you got to buy that for like $3 for the clone, which is good. Or I think, again, $10 or $20. I can't remember, but the programmers are great. Onboard debugging is incredible. I have to have it. I will use serial debugging also for certain things, but I have to have both. And I will not go back to programming in like the Arduino IDE, which I already ranted about that a little bit. Platform IO lets me use real deal debugging. And the ability to stop at breakpoints is just something that I can't. It may save me an hour here, an hour there, and those hours add up. You got to have that feature, that tool. Let's see. The ability to scale way up and down. I can get microcontrollers in the STM family that are super, super high, super, super fast, super, super slow, super expensive, super cheap. And I like being able to immediately adapt my project if I need to. They have that STM32 Black Pill, which is significantly faster than the Blue Pill. I bought some from China. They didn't work. Pretty funny. So who knows? Who knows what's going on there? But I would like to see an American option. And again, I've considered making my own. How much would they cost? How much interest is there? How many people like this thing? I don't know. But overall, it's a winner. Even though you got to deal with this basically the Chinese part. And again, I would definitely pay $5 or $6 and to not have to think about it, to know I had good ones. To whenever I'm troubleshooting another junky, stupid circuit, it'd be nice to say, at least I trust this microcontroller. Because oftentimes now I'm like, well, it's probably just a damn junky microcontroller that didn't pass in China in the first place. Okay, so that sums up this is the second episode of the Electron Injection Engineering Podcast. I think I might take engineering off of that. What do you guys think? You guys tell me. Out. Oh yeah, I can't forget. For you YouTubey types, like, subscribe, all that stuff. If you like what I'm doing. If you hate it, just tell me. Tell me use a bunch of cuss words. Tell me what a piece of poop I am. You know, I'm trying to be good on this particular podcast. I can get nasty too. All right, guys, see ya.